Welcome everybody to the Network Instruments presentation. My name is Charles Thompson. In today's session, what we're going to be discussing are a few of the recent enhancements which have been made to the Network Instruments performance management solution. We'll start off by talking a little bit about the Network Instruments architecture and then dive into a few of the recent enhancements. The Network Instruments performance management solution is comprised of a number of different components. If we start off along the top of the monitoring model, what you see is the Observer Reporting Server, which is our aggregate performance management platform. It has the ability to take in data feeds from packet, flow, and resource data sources and aggregate this information to allow organizations to get an enterprise view of their overall performance metrics. Then, using a top-down workflow, organizations can drill down for root cause analysis into the Gigastore, Observer, and the Observer infrastructure products. Now, with that architecture in mind, let's take a look at a few of the recent enhancements which have been made to this overall platform. First, application dependency mapping allows organizations to understand the interdependencies which exist in their service delivery environments. Now, not only can organizations understand the client-to-server communication which exists, but also inside of a multi-tiered application, you've got the ability to break out the communication which exists between the application servers. And when application performance begins to degrade, organizations can quickly isolate which component of the application delivery is impacting the end user experience. So not only are application dependency maps critical for being able to troubleshoot issues when they arise, but they're also important as you start to migrate from traditional infrastructures over to new environments, like for example, virtual or cloud-based environments. So as organizations are moving from their traditional physical infrastructures out to these new environments, they need to understand not only which application components rely on one another and thus need to be migrated in tandem, but also need to understand the communication which exists so that as they migrate these components, the communication paths can be set up in order to facilitate all the transactions which will need to occur in order to facilitate serving the end users. If we take a look at this inside of the interface, you can see that I've got currently set up an application dependency map showing a traditional IP telephony environment. We've got a few different call servers in the environment and a number of Cisco Skinny endpoints which are communicating to both call servers. These clients are experiencing positive performance levels with the servers, as are the servers with one another, as illustrated by the green lines. If I hover over a green line, I can see the level of performance that's currently being experienced by our clients to each server. Now in this environment, we also have web clients which interact with our call servers. And those web clients are currently experiencing marginal and critical performance degradation. By double-clicking, I can drill into the application dependency map to get a table view for more detail of the communication. Now additionally, from here, I can drill down into these aggregate values of performance to be able to break out the individual client performance levels that are being experienced. So I know exactly who's being impacted by the degraded performance. So application dependency mappings are not only great to be able to identify which components are involved in communication, as well as which components are degrading when application performance begins to suffer, but they also help organizations to migrate technology into new environments. Moving on, Network Instruments has introduced new performance matrices that allow organizations to expedite the triage of application performance issues as they relate to both the application itself as well as locations or departments within an organization. Traditionally, organizations looked at application performance in a fairly aggregate display, looking at the overall performance of email or web-based transactions or CRM communication. With the new performance matrices from Network Instruments, organizations have the ability to get a far more granular view at performance. Again, coming into the interface, you can see that in my particular display, I'm tracking two applications, a CRM and an IPT application environment. And in my first matrix, I'm tracking performance by site. So I'm looking at each application's performance as it's experienced from two physical locations, Dallas and Houston. Now additionally, inside of our organization, we've got a CRM application which is leveraged by our sales, customer service, and logistics teams. And each one of those departments inside of the organization leverages that CRM application for entirely different purposes. Therefore, they're interacting with totally different elements inside of the CRM application. Now, this results in needing to be able to understand the performance as it's experienced by each department, since a performance degradation that impacts customer service may have no impact on sales, and thus aggregate metrics are simply not applicable in this particular environment. So in my bottom display here, you can see I'm looking at performance by department, where I'm tracking the same two applications, but instead of viewing by physical location, I'm viewing it broken down by department. And the great thing about these new performance matrices is that organizations have the ability to both narrowly and broadly define not only the application, but also the logical performance groupings, which means that in your organization, you can group by site, by department, or by any other logical grouping which would make sense. For example, you might want to group the performance of your internal users versus external consultants. Finally, performance correlations allow an organization to understand the relationship between performance and resource consumption. Coming back into the user interface, I'll search on a particular server. And in this case, I'm looking at response time, graphed in yellow, against the number of observed connections and the total volume of data being exchanged with this application server. And I can see there's a definite relationship between the response time my end users experience and the number of transactions and the volume of information being exchanged with this application server. Now, if I were to see a disproportionate rise in average response time when compared to the number of observed connections and volume of data being exchanged, it would be a clear indicator that there's a performance degradation inside of this application that is quite likely related to a resource consumption issue, and that this application server is simply resource constrained. This would tell an IT organization two things. Not only would they be able to quickly address that issue by providing more resources to the application server, but it would also allow IT organizations to better understand where to invest resources moving forward in order to ensure acceptable levels of end user experience across all their different applications. Those are just a few of the recent enhancements that have been made to the Network Instruments solution. For more information about these and other enhancements, please visit us on the web at networkinstruments.com.